containment, and that sits inside another box called a secondary containment. So there's a pressure cooker inside a box inside a box. The things that blew up at Fukushima were the secondary containment. So if everything worked fine, there's still the reactor, and there's still the first box, or the primary containment. Well, on Unit 2 at least, the core has melted through the reactor. And so the pressure cooker's got a hole in the bottom of it. And on Unit 2, and this is the one that actually looks the best, by the way. It's the one that still has the blue box above it. The containment has failed. There's a crack in part of the containment. So they're pouring water in the top to cool it. It's running out the hole in the bottom and getting collected in the containment, except the containment isn't containing. And so that will contain all the witch's brew of isotopes. That'll contain, the cesiums and strontiums and radioactive iodine and plutonium, because it's in direct contact with the fuel. The fuel is now a lump at the bottom of the containment. So it's in direct contact. The water is in direct contact with the fuel. Now that's running out. That's running into trenches that weren't designed to hold it. That may be cracked. I think they are, because they weren't designed for the earthquake. And those trenches are then leaking into the Pacific. So they are just now, they announced yesterday that they were going to be looking at the sediment on the bottom of the Pacific Ocean to look for plutonium to see if it's there.
What does it mean when you say 100 rem per hour in radioactive water and that the condensers are not seismic at Fukushima?
Well, let's go up a little bit. 300 rem, roughly, is a lethal dose in an hour. So between 300 and 400 rem, if you were exposed to that for an hour, that would be very quickly a lethal dose. So 100 rem would mean that if you stood in that water for 3 or 4 hours, you would die. We're not talking about die 30 years from now from a cancer. We're talking about die in the next couple of weeks. It causes neurological breakdown, and it also ruins your gastrointestinal tract. So at those levels, when you hear REM, not millirem, but REM, especially hundreds of REM, you're talking about the likelihood of death very quickly. So the puddles those guys were walking in a couple of weeks ago were over, their instruments actually went off scale, they were over 100 rem an hour. And so several people were exposed to quite high levels of radiation at Fukushima. So the water is incredibly radioactive. Now they needed some place to put it. And so there's this big tank called the condenser underneath the turbine. And the plan was that they would pump it to the condenser as a place to store it, because they were running out of tanks. And but that's not designed for an earthquake. And the question is, was it intact after the earthquake? And nobody knows. So they're pumping all this water into places that may or may not have any structural integrity.
The thing that I don't get is, how can the condensers not be seismically fitted? I don't get that.
Yeah.
I don't understand it.
A nuclear plant's got two parts. The safety-related stuff. That's the nuclear reactor, the nuclear containment, and that pipe. And that's built to nuclear standards. But the rest of the power plant is built as if it were a coal plant. It's built to industrial standards. So that actually the place where the electricity is made, the turbine and the condenser, is not robust. At least it's not as robust as the containment itself. So that and actually that's the big building. If you look at the Fukushima pictures, there's this really long building along the ocean, and that's the turbine hall. And it is it's not designed to withstand the big earthquakes or the big tsunamis or anything. It's the next building the buildings that are blown up, that are the ones that contain the, quote, safety systems.
It's just wild. It really goes to show you that you're only going to be as good as your weakest link.
Yeah.
And this is pure evidence of that.
Here in the States, we that standard applies too. And we have, let's look at Vermont Yankee. They claim, after the fact, they've gone back and reanalyzed their condenser, and they said, well, in most earthquakes it won't leak, so that's pretty good. But in fact, if you look at the likely earthquake by today's standards, it wouldn't withstand it either.
Why do you think it is that the Nuclear Regulatory Agency in general, around the world, and why do the power plants get to choose what's safe? Why do they even have the dominion and the authority to say what's safe? Can't there be a different frame of reference imposed on all of them, including the Nuclear Regulatory Commission, where the public will say what's safe, not them?
I think they would claim that the public does make that recommendation because Congress tells them what to do. But in fact, what's happened is the Nuclear Regulatory Commission is run by 3 commissioners, all of whom are appointed by Congress. Every year, one is appointed. So every 5 years, you lose your job or you get reappointed. And the industry, the nuclear industry, has been instrumental in appointing every commissioner for the last 20 years. Because, they lobby Congress. So if when a commission slot opens up, people like me or Dave Lochbaum at Union of Concerned Scientists don't get considered because the industry doesn't want us to get that job. It's only people that the industry wants to get those jobs gets the job of overseeing the industry. And it's been known. It's not a surprise. As a matter of fact, NEI, the Nuclear Energy Institute, the organization that promotes nuclear power, has openly bragged that it has vetted every commissioner since 1993.
See, that's a conflict of interest that's too dire to be allowed to continue.
Well, I would agree.
It is the fox guarding the hen house, truly.
Yes.
Actually, it's the fox guarding the fox house, I should say.
Pete Domenici, who was a senator or representative back in the 90s, wrote a book, and he openly brags in the book about pushing the Nuclear Regulatory Commission around, and they were taking too long to make approvals. And he threatened to cut their staff. He threatened to cut their funding. And they waffled. So this isn't something behind the scenes that's happened. Influential senators have actually written books about how they pushed the Nuclear Regulatory Commission around.
I want to talk a little bit about Areva, a French nuclear company, and the report that came out. Would you like to talk about that?
Yeah, it was an interesting report. Areva they build pressurized water reactors and not boiling water reactors. And the Fukushima reactors are boiling water reactors. But they got a by invitation only conference out at Stanford about a week and a half after the accident, and they really painted a pretty horrific picture of what the problems were at Fukushima. Now, you and I weren't hearing that. We were hearing what the press was telling them, which was that things were pretty much under control. There might be some bumps in the road. But the Areva report, it's up on our website, by the way, the Areva report showed that things were quite dire. Now, Areva has skin in the game. They obviously want to build nuclear power plants in the future, and they have the backing of the French government. But the report they were giving to people behind closed doors was dramatically more concerning than what the press was telling you and I.
What people were there? Like, what kind of people were invited?
I'm not sure. I'm sorry.
Okay, no problem. How did you find out about the report, and how did it get to you?
I found out about it from someone who worked for the United States Senate years ago and is retired. And this person's just really well connected and sent me a copy of the report. But it was through back channels that we were able to get that report. And since then, Areva's even taken its name off the report. I happen to have a copy that was